As I stated, we're going to start off by talking and motivating multivariate regression with our example from last time. So if you remember, the data looked something like this, where we were interested in deriving the best line through the data, which is our covariate, Q2 GDP growth, and our outcome, the share of the vote that the incumbent party received. And we might ask, well, that's nice, but there might be other things that are driving people's considerations. And one of those things may be, not only the economic performance of a president, but just whether or not that person has been in office for very long. Like people kind of get sick of politicians. And so we can see here that on average, as candidates have been have been either in office longer or their party has been, they do worse. Typically, people like voting for the other party. It's time for a change. So let's think about how do we adjust what we know about bivariate regression to solve this problem. And there's nothing really notable what we're going to do. We're just going to make a more complex equation here where we take what we had before, where we're interested in, again, estimating what the mean share of the incumbent party was. And we're predicting that with, again, Q2 GDP growth and now our new variable indicating whether or not it's the incumbent party. And again, just for you to remember what the symbols are here, that mu y is the mean presidential vote share. We're predicting that, right? We're predicting the relationship that Q2 GDP growth has on presidential vote share, where x1 is the actual data point that we observe of Q2 GDP growth in that election year. And then that beta 2 is going to be the estimated relationship, the slope or coefficient for that time for change variable. And we're going to use a dummy variable here where 1 is going to equal whether or not the president's party is only in their first term or whether or not it's their second or third potential term. Where you can imagine a scenario, maybe a party has been in power for 2 or 3 presidents, right? That would be like 8 terms then. And then we also have our beta naught, which is going to be the y-intercept or y bar when, and I want you to think about this for a second, because in the bivariate case, it's when Q2 growth is at 0. But in this case, since we're adding an extra variable, then the time for change variable also has to be 0. So when both x1 and x2 are equal to 0. We can then write out our regression equation. Let's say if we get some estimated coefficients from a regression model where our y-intercept is 46.59, beta 1 is 0.76, and beta 2 is 6.02. Now, another way to represent that, because this is a dummy variable, remember, where time for change can be 0 or 1, we can rewrite this equation when it's either 0 or 1. So when it's 1, you can see if it's 1, or in other words, just the first term, right? So not time for change, that's the bottom one. It adds an extra 6.02, so 52.61 instead, plus 0.76 times whatever the second quarter growth is. And then time for change, right, is the second or more term. So when that equals 0, therefore it just negates that last term, and we just have 46.59 plus 76 times whatever the Q2 growth is. We can also visualize that relationship where, again, we can see the disadvantage that the incumbent party may face with the red line, and then the advantage that a newcomer might have with the blue line, and then the average that we have when we pool them all together. So when we ignore this variable altogether, that's the dotted line. Now, we'll get into this in a bit when we start talking about lines within groups, but again, this is essentially what we're doing when we have a dummy variable. We're just estimating separate regression lines for these different groups that ultimately have the same slope because this is an additive model, right? We're adding that variable to our regression equation.